So last class we discussed about the searching techniques, and also I wrote algorithm for linear search, and also I told about there are two methods of searching. So one is called the linear search, another is called binary search. So in linear search there is a disadvantage. So what is the disadvantages means the time taken to make decision of element not being present can be made only after comparing all the elements. So this is a time consuming. So therefore we come up with another technique called binary search. So in binary search what we do means, already as I told, so the element to be searched is compared with the middle element of an array, and there may be three possibilities. The middle element is the element you are looking for. In that case, the search is successful. We note down the position. So, in another possibility is, other two possibilities are there. One, the element what you are looking may be greater than or may be less than the middle element. So, if it is greater than means we have to search the right half of the element. If it is less than means we have to search left half of the elements. So, if you take an example here, if you write like this, there are some elements. This is an array with some elements. You can take, this is an array A. So where we are going to store the elements. In this case, let us take an example: 2, 4, 6, 8, 10, 12. So binary search is applicable only in an array where the elements are sorted. So otherwise binary search is not applicable. The restrictions with the binary search is the before applying on binary search, the elements need to be sorted. So only sorted element, this binary search works. So now what I am trying to do means, so let us take the subscript 0, 1, 2, 3, 4, 5. So half of it means 2. So this is the middle element. So middle position. So then we take the middle element. So suppose you are looking for some element, assume some like 20. So take the middle element as 6 and 20 or compare. If they are same, the element is that the search is successful, we conclude. Otherwise, what happens in this case, 6 and 20 are not same. So what is other option is 20, what is looking for is greater than 6. So if the element is present, it must present after this. So therefore, in the first comparison, we eliminate half of the element. So then we search. So if it is the beginning, this is the end, lower bound, upper bound, this is the middle element. Then we search on the right half of the element by excluding the left half of the element. Then we get a new, like this is the beginning and this is the end. So then again we find the middle element, then again we compare. So this process is repeated from beginning to end. So we end up with two options. One, the search may be successful where we find the element. Another is there are no more elements. We keep reducing. So we had like midpoint formula. So we start with the beginning and then we reduce to half. Then also we reduce to half. So finally there are no more elements. Then what we do means we conclude the element is not present. Imagine this is between you can take, then we'll get the middle element. Then we search the left half or right half. Again we apply the recursive. There are two methods. Binary search can be done in recursively and non-recursively. If I use a recursive, so it becomes very complicated to implement. So therefore we don't use recursive. So in this case we are using the what we call non-recursive approach. So we take and we keep repeating these three steps. What are the three steps means? Getting the middle element, comparing with the element to be searched. So there are now that may be the same element, or it may be greater than, or it may be less than. If it is greater than, search right half of the element. If it is less than, search left half of the element. So this process is repeated until there are no more element exist. There is no more element to be searched. So this is what we call as a binary search. So let me write an algorithm. Then we'll take an example. Then we'll understand. So same procedure. We have to write let A be an array with B is pointing to the beginning element and E is pointing to the last element and LOC will be used contains the address. So it is in the textbook, copy that algorithm. So I am explaining only algorithm, remaining you write. So what is algorithm means? As usual, we start with step 1. So start. So there are some assumptions we have to make here. So first is we take as usual. So location is equal to -1. So then we make the b equals lower bound 0, e equals n minus 1. So where n will be the number of elements, and e is element to be searched. So this is we make an assumption. So next, let us we repeat the process. Like repeat the following step, like y. So b is less than or equal to e. That indicates as long as there exists element between b and that's lower bound or upper bound. We will give an example. I will show you how it works. So then what we have to get the middle elements. How do we get the middle elements? So we will do b, that is middle position will be b plus e divided by 2. So here we have to take integer mode of division. So we do not consider fractions. We can consider only integer part. So after the middle element we got, position we got. So but we want the element means that has to be compared. So we take now. So if here is the element to be compared, is compared with a of m. So m is now the position subscript. It's average. So 0 plus, if it is a 5, there are 5 elements means 0 plus 5 divided by 2. Take an example. So that is we are comparing. So this gives the position and a of m gives the middle element. So next what we do means if the middle element is same means we copy the location is equal to m. So that is where the element and the middle element are same. So what we do means in that case the search is successful, we stop. So that is we go to some step number like good consideration making element is found and we stop. Otherwise else what are the possibilities? As already I told, it may be greater than or it may be less than. So whatever it is, let me take. If element you are looking for is greater than a of m, that indicates. So if at all, if it is exists, it must available on the right of the element. So then what we do means we change. So new beginning will be m plus 1. So m is present element. We take an example, it follows step. Otherwise, so else. Else means b is not equal and it is not greater than also. So obviously it will be less than. So then n will be reduced. So n will be m minus 1. So repeat this process until this step y. So repeat this. You can give this step number 5. This is 6. This is 7. This is 8. This is 9. This is 10. So next what we do, so 11 in step number 11 here, what we do, this will decide whether the element is present or not. So if at all it is present, the location will be having some positive value. Otherwise, the element remains negative as usual in the previous case. So there we make a decision if location is greater than or equal to 0, same procedure. So output, so element found exactly similar, found at LOC. Else, output, search is unsuccessful or not found. Anything what you want you can write, not found. This is how we can write. Element is not found. So next to stop is step number 12, you can stop. This is how we the ends. So if it is this elements and the middle element of an array are same means we copy it, that is the location, and immediately stop this process of repeating. So go to step number 11. Exactly the same. So where location was earlier -1, it is reset to this what we call positive number m. Then we display the element is found at an LOC plus 1. Let us take an example. We take some numbers. We follow this algorithm. We apply the process. Let us take some elements. So we apply this binary search already explained. So in binary search, what we are trying to do means we try to find the occurrence of the element in given set of numbers. So we have an array where the elements are in order, that is in ascending order or descending order. We take an example of ascending order. Let us take some numbers 2, 4, 6, 8, 10, 12, some numbers. So there may be any number of elements. So here what happens? Let it be subscript 0, 1, 2, 3, 4, 5. So there are totally 6 elements and it is identified by name. An array, let it be right A. So this is an array. So now let us take an example. So we are looking for some element here. That is, you are looking for, let us take where search is successful. Sometimes we go for 12. So definitely when I ask you people, so you know that 12 is there exists an element, you can count. So to answer this, the element is found. So you can say the search is successful, element is present. So let us apply this binary search on this set of numbers. So let us start with the B. What does B means? 0. What is E? Equals n minus 1. So what does n means? So we have 1, 2, 3, 4, 5, 6. So n becomes 6. So what does this? N minus 1 means 5. So B is 0 and then E is 5. That is 6 minus 1 is 5. You can see here n is 6 minus 1, 5. So now what we do means we apply this procedure. So now, and also remember location is minus 1. We'll follow the step now. So while B is less than or equal to E. So what does B means? We have a 0. What does E means? We have 5. So now 0 and 5. 0 is less than 5. Yes, it is true. Repeat these steps following till while n. So all the steps has to be repeated as long as this condition is true. Now the condition is true, repeat now. So we try to find m. So what is m means? It is calculated. So m will be b plus e divided by 2. So what is b? 0. What is e? 5. 0 plus 5 divided by 2. So 0 plus 5 is 5. 5 divided by 2 is 2.5. So we will take integer division. So it will be take integer part of the quotient, that is 2. So m becomes 2. So that is we got the middle position. So when you take this array, so this becomes the middle position. First comparison we are making. So middle position will be now right now pointing to 6. The position is 2 and the element corresponding element is 6. The element what you are looking is 12. So now we compare. Next step we are comparing. So we got the middle position, then we compare. What is the element you are looking for is 12 and what is the present element? So A of m. So A of 2 is A of m which is 2. We have 6. Element is 6. Now elements are compared as 12 and 6. 12 and 6 are same? No, they are not same. So therefore what happens? We go to next statement here, if statement. Because put this if is false, we comes here. Else, his element is greater than A of m. The element you are looking is 12 and present middle element is 6. 12 is greater than 6? Yes. Then what we do is, if at all 12 present means, it must come after 6 only. Because elements are sorted. So if at all present, it must exist after this. So therefore what I do means, where we had beginning, I'll reset. So I'll eliminate this off of the elements. So I'll make this is beginning. End is here only. 5. So how do you make this one means? So how do you make this? So if it is m means, what will be its position? It is m plus 1. That's what I did. So when I make the beginning which was pointing to 0, so now after the statement b equals m plus 1 means, so it is m plus 1 is 3. So this one of an array will be eliminated. This is for understanding, I just did it. So now this becomes an array. So where we have to search. So this is doing the first comparison. Half of the elements were eliminated, but they exist. For understanding only, I did like this. So now apply the same procedure after the statement. So while n, come back to the beginning. So what is the b value now? It is replaced, which was earlier 0. Now it is replaced by n plus 1, which is 3. Now e remains same. So now we compare. B is 3, E is 5. 3 is less than 5. Yes, repeat. Again, it is 2, repeat. Find the middle element now. So that's what I said, recursively apply the same procedure of finding the middle element and compare it and repeat this process. So now the element you are looking for is B plus E divided by 2. So it is 3 plus, what does E means? 5. 3 plus 5 is 8. 8 divided by 2 means 4. So we got, this is M now. So M is pointing to this one, 4. So element you are looking is same 12. So A of 4. So A of 4 is, we have element 10. We are comparing 12 and 10. So 12 is greater than 10. 12 equal to 12, 12 equal to 10. False. 12 is greater than 10. Yes. Then replace it. If at all 12 is present means it must come after 10 only, because the elements are sorted. So therefore what we do? We search the right of the element. So here it is M. So M plus 1 will be. So M is 4. 4 plus 1 is. So now B. B becomes 5. E is also 5. So now we remove these two elements. So in this case, we left with only one element to be compared. Yes, possible. We took very less number of elements. It is like this. You take 5,000, 10,000, 20,000 elements. The process is repeated many times. So in this case, I do only 6 elements. So it's therefore it has come down this. That's why I use why equal has to be considered. Equal means there exists only one element. So now what happens? So B is also same, E is also same. So get average is same. So 5 plus 5, 10 divided by 2 is 5. So now the middle element is also 5. So M is also 5 now. So M becomes 5. So element to be compared is 12. A of M. A of 5 is also 12. 12 equal to 12? Yes. So copy the position. So M is copied to LOC. LOC which was minus 1 is replaced by 5 now. So M the location becomes 5. So immediately go to step 11. Don't want to repeat again, just you go. Suppose the first element itself is the element you are looking. So in first comparison only we quit and we decided the element is present. That's what I am trying to do here. So because I took some example how the processing has to be repeated. To understand this one, I till the last element. It can be any possibility. I took worst case possibility. Now what we do is go to step 11. So step 11 here, location is greater than 0. Yes, what is location? Right now is 5. 5 is greater than 0. Yes, element bounded. Location plus 1. That is 5 or we can write 6. So stop the algorithm. So if we give 12, so display the message element bounded 5. So that is where the subscript value 5. Or you can write number of position means 6. So now this is the example where the searching works efficiently. Suppose when it is unsuccessful means, suppose instead of 12 you are looking for 22. The same procedure is repeated. So now we got 22 is compared with the 12. Same example. So 12 and 22 are not same. So therefore 22 is greater than 12. If at all 22 exists, it comes after 12. So therefore we set B is equal to M plus 1. What is B? Right now is 5. What is M? Is also 5. So now the new value B becomes 5 plus 1, 6. Now look at the condition. 6 is less than or equal to 5. False. That is where we compare all the elements. There exists no element. So therefore we have to conclude the element is not present. That's why we have to include the last element. That is equal means that is the last element. So how long we should repeat this process of finding the middle element, comparing with the middle element? This has to be repeated as long as the element exists. The range of numbers. That is between B and less than or equal to E. Equal means there exists one element. Last element, both is pointing to the same element. So after this, when B crosses E, there exists no more elements. So that is where we quit this process of searching. That indicates indirectly. For us, it's very simple. Human eyes, we can make out that saying there are no more elements. This is how mathematically we can conclude there are no more elements. How machines can do means such kind of decision without seeing also. With human eyes, we do these things. Now we may conclude yes, it is the end of there are no more elements. How the same thing can be done means that is with the help of mathematics. This is how mathematically it identifies there are no more elements. That is the why B is less than or equal to E. That's how computers can able to do this decision making option. So it can make automatically decide. So we are not, machines are not seeing, but still the they do correctly. I give 20 numbers, it's working. I give 10 numbers, it's working. I give 100 numbers, it works, because we take this mathematical conditions comparison. B is less than or equal to E. As long as there exists element, repeat this process. That is the reason. So now we display it remains negative minus 1. So not found. 22 is not found. So it is not confused. I will not repeat it once again with the same set of comparisons. I told you the same thing. Instead of 12, you repeat it for 22. The same thing would have been repeated. Same steps, and then this is the last step where we terminate the repetition and we decide the element is not present. So this is the binary search algorithm. This is how binary search algorithm works, and we can write a program for this and you will understand this one. So we have for practical manual also we have this academic, we take this one for practical. So this algorithm you write in exams, they may ask for. So explain binary search algorithm with example. So I write this binary search algorithm. And also some practical, we have a binary search. You write because you are familiar with the C program, so C rather than going for C++, that is in the C++. I will repeat it once again, but here also write once with which programming you are familiar with. C will write structured programming. As usual, we write program and we put an array, the same procedure. Then we take this. This has to be included. So this also the same. And beginning this input is also same, but this is the additional part, so the processing method. So I think this is the textbook, you can copy. So let me write program now. So it's very simple. So whenever we do programming units, I already have told there are 3 steps. I think we remember in the program, when you write programs means divide the program into 3 parts. One is, that is what taught us, that is the top-down approach has been taught us. So divide the problem into 3 subtasks, that is input, processing method and output. So first, the input will decide, so what are the input required, how many variables required, all those things can be written down, the declaration section. And then output tells what are the values should be output, and processing method also exact procedure. Now binary search. It's very simple. Most of you are familiar with. Just I wanted to remember how to write the programming. So we start with the dividing the problem. That is, write a program to find that is the element is present or not using binary search. So here we had to search. So therefore we need an array. Divide this problem. What's the input? So this is a binary search requires an array, the searching process. So we need an array. And what is the other thing you need? Whenever you declare one dimension array, you need the subscript, you size of an array, and then the element to be searched. This example. As usual for output, we need location. So a string constant message, element is found, element is not found, successful or unsuccessful, that you can write. But also you need the location, that is to make decisions, negative or positive. Previously we have did the same thing. So location we need, and we use additional 2 variables here like b instead of just n only. There we use a for loop for I is equal to 0 to n minus 1. We did directly. Here what happens? We have to find the middle element. So therefore we use additional 3 variables, that is b, that's the lower bound, and then e, that's the n. So beginning n, and then also we use m, that is to find the middle element directly, position. And we repeat this process. So these are the variables required. So let me write that variables, what are the variables we require. As usual, I start with void main. So void main program. Now decide what are the variables we require. So what are the variables? First, use an array. So we can teacher a of 10. So we need an array. Then what we need? So once declare one dimension array. So we need subscript. We need the number of element n. Then we decide the other additional things. So LOC is needed, then we needed beginning, so then we need, so you can use here only declaration, location is equal to -1, comma, then you use b equals also 0, and then we can use variable e, but don't write here e equals n minus 1. So after input only we initialize e is equal to n minus 1, or b and e we initialize later on. So when before this start processing starts, we initialize. Let me declare variables. Is there any variable is required? Yes, of course, n is required. So these are the variables. If necessary, we declare them, no problem. So let us start with, as usual, see out. So enter size of an array. So enter n, that is number of elements. How many elements are there? So input. Enter number of elements. So C n input the number. So that decides how many elements. 10 means 10 elements, 20 means 20 elements. Next, so C out, so enter the number of elements. Message, so enter elements of array. So just write enter elements, so that will be nothing but elements of array. So we can write elements of an array, enter the different numbers and all. So here the elements is not a single, so we have to repeat for one dimension. For I equals 0, I is less than n, I plus plus. So repeat these number of elements. So that is C A of I. So A of 0, A of 1, A of 2, A of 3, A of 4. How means till the end. So there exists n number of elements. So what is another input from the problem statement? You can make out. One is an array, another will be the element to be searched. So enter here element to be searched. This is very important. Element to be searched. You can write this one into element to be searched. End line, string constant. So what is the element we took here? The same thing which we have used yearly. I think yearly or not declared here. So that's what I said. We'll define it. So element will required. Is there anything is required? Let us make a assumption. Before next is this is the input part. When you write object oriented programming, we make functions. This is the input, then processing method, then output. So it's simple. So far we did these statements. Input, creating an array. We are writing let A be an array with some element. This will does that part. So we create an array. This part it is like imaginary. So when these statements are executed, it becomes like this. So an array with some elements. Let me take like this. The same elements we count again 2, 4, 6, 8, 10, 12. So this is an array. So we have A. So after this statement, we input the elements like this. So here n becomes, so n is in this case 6 element, and then we have element to be searched. Here I make it yearly. Let me take this is something you will take 1 second comparison. So that is 10 we are looking for. So next what happens? This is so far what we did, the program does. Next is processing. So what we did in algorithm, you remember. I started with location is equal to -1, it's already done. Then b is equal to e, what is the beginning? We have to write 0, lower bound. And also we have to e equals n minus 1. So here n exists. Why I have not used here itself means we have to input n. So after we got the number of elements, that will be the upper bound, that is n minus 1. So e equals n minus 1. Both are semicolon, two separate statements. Next one, after this, we use a while, same procedure. So while b is less than or equal to b, same procedure we have to repeat. So when b is less than or equal to b, what we do is, let me write here flower bracket. So we start here. So what we have to do? We have to find the middle element. So m equals b plus e divided by 2. So here what I am saying exactly similar. So we'll find the middle element. After finding the middle element, comparison. If element you are looking E and B double equal, where you use relational operator. So equal to A of n. So the element is found. That is the element you are looking for and the element in an array, both are same. So there we do two statements. One, we copy the location. So therefore the location will be m. Then we took I, here it is m. So after this, as usual, so stop repetition. Once we got the element, no need for repeating this while. Then we have for loop. Here we don't know how many times we have to repeat from beginning to end. So therefore we use keep repeating. Therefore we use instead of for we use the while statement. So after this, stop. So suppose otherwise else means it may be greater than or it may be less than. So if element is greater than middle element, the element you are looking is greater than. So greater than means it is present after this element. So therefore, we replace. The new beginning will be m plus 1. The same algorithm, but we put semicolon here. So otherwise, not equal, it's not greater than, hence it will be less than. So therefore, then you search the left half of the element by reducing e equals m minus 1. So if it is you are looking for is something like, now we got middle element 6 and you are looking for 2 means, so 2 is less than 4. If at all present, it is before 6. So therefore, the e will be replaced. So in either the case, we remove left half of the element or right half of the element depending on the element you are looking for. So next, so this is end of while loop. So this is repeated. So keep repeating the steps. After this, we quit the loop. As usual I told. So completion of this loop. So here we have addition. Same step. So LOC is greater than or equal to 0. So C out. There we wrote output. Here you write C out. So element form that LOC plus 1. So here else C out not found. End line. So this is the program which will be completed now. This is how we write the binary search algorithm. So you can take an example, this example. So let us we go with the example. So we took 2, 4, 6, 8, 10, 12 is the number of elements where we are going to apply this searching technique. So now, so look at this n. So what is the n means? Number of elements, which will be, we'll take an example, 6, and see here 6, and then we have element to be searched, we input, which is 10. So we'll apply this process. So b becomes 0 and e becomes 5. So 6 minus 1 is 5. So b 0 and 5. 0 is less than 5. Again repeat same. So we find the m. So what is m? b plus e divided by 2. What is b? 0 plus 5. 5 divided by 2 means 2.5. 2.5 means the integral part of the quotient is 2. So m becomes 2. So element you are looking is 10 and a of 2 now. So a of 2 is, so it is 0, 1, 2, 3, 4, 5. So a of 2 is 6. So element you are looking is 10. Present element is 6. 10 and 6 are not same. So therefore, we go for next step else. So element what you are looking is 10 and what is this element is 6. 10 is greater than 6. Yes. Then what we do is go to the next y. So thereby increasing m plus 1. So b becomes m plus 1. b previously which was what we thought was 2. So now it becomes 0 m plus 1. So m is 2. 2 plus 1 is 3. So now this is the beginning now. So b becomes, we have here. So this remains n same. So now we have to search 8, 10. So after the 6. So repeat now. So what is b? B is 3. What is e? 5. 3 is less than 5. Repeat now. So b plus e means 3 plus 5 is 8. 8 divided by 2 is 4. So m becomes 4. The new value of m is 4. So and what element you are looking is 10, which is, what is the element you are looking for is 10. So a of 4 is also 10. 10 equal to 10. Yes. Then copy the location which was minus 1 is replaced by m. So location becomes, which was minus 1, now it is becomes so 5. So that is sorry. So it becomes a 4. So m is 4. So location also becomes 4. So break immediately, stop this while loop. Go to next statement. After the break is we have this one, this statement. So location now 5 is greater than 0. Yes, display element is found at LOC which is 4. So 4 plus 1, 5. Element is 5, found at 5, 1, 2, 3, 4, 5. Subscript value is 4, therefore I put plus 1. So this is how the binary search works. This is a programming example. To write this program, So it works for any number of elements. If you increase the size of an array, 10,000, 5,000, so 10 elements or 5 elements, 6 elements. So this is the easiest method of searching or the method of searching. So next class we learn other operations like insertion, deletion in the next class. Thank you.